Hello, and in this video, we're going to be exploring a little bit more the idea of work. Now, in a prior chapter, What is Energy, we saw that work is a force, a push or a pull, applied for some distance, and that work is one of the two ways that I can either add energy in or take energy out of a system. In this video, we're going to be exploring that idea in a little bit more detail. Do all forces result in work, or only certain forces in certain directions? And furthermore, when does work put energy into a system, and when does it take it out? Once again, we're going to use this idea of a little toy truck to explore the idea of work. So as we saw in the first video, if I apply a force for a distance to the truck, like so, then the truck increases its kinetic energy. I'm adding energy to the system by applying a force for a distance. But do all forces add energy to a system? No. If, on the other hand, the truck is already moving and I apply a force against the motion, like so, I bring it to a stop. I take energy out of the system. So clearly the direction of the push matters. If I push in the same direction as the motion, then I will add energy to the system, like so. In contrast, if I push against the direction of the motion, give it a push and push against it, I take energy out of the system. What if I push at an angle? Well, if I push at an angle, like so, then I still add energy, but I'm not as efficient at it. For the same amount of push from my finger over the same distance, I don't get the same addition of energy. Some of the force is kind of going into the table instead of going into energy of the truck. So if I push fully parallel to the motion, that's how I get the most energy into the system. If I push at an angle, I still add energy, just not as much. This might be getting you to think about angles, which might be getting you to think about trigonometry, which is why we have that section on reviewing trigonometry and the signs of the sine and cosine trigonometric functions as additional prep for this chapter. Similarly, if I push opposite the motion but at an angle, so if I push directly opposite the motion like so, that's how I get the most stop, right? That's how I take the most amount of energy out the most efficiently. In contrast, if I push at an angle, I don't stop it as efficiently. I still take energy out of the system, but it's not as efficient as if I push directly opposite the motion, like so. Or if it's moving and there's a force perpendicular to the motion, which there is, right? The gravity is pulling the truck down. So there is already a force perpendicular to the motion of the truck. And we see that that force doesn't change the kinetic energy of the truck. So let's summarize what we see here. Forces that are in the same direction as the motion add energy. Forces that are opposite the motion subtract energy. Forces that are perpendicular, like the force of gravity that's holding the truck to the table, don't change the energy at all. And if I push at an angle, I can still add or subtract energy from the truck, but I just don't do it as efficiently. This concludes this video.